Good morning, students. In this session, we are going to see a subject, hybrid and electric vehicle technology. From this subject, today we are going to see a topic, power flow control in electric drivetrain topologies. What is electric drivetrain topologies? Based on the different topologies, DC motor can be categorized into three types. They are series excited, shunt excited, and separately excited machine. Both shunt and series DC motor have only one voltage source, hence the control of the flux and torque was stimulation. The electric vehicles which offer zero emissions during the driving are quickly gaining market share recently due to their increasing practically. Contributed by the latest technology advancement made particularly in the areas of energy storage and charging systems. Together with the recent developments in terms of emission control, worldwide the market share of electric vehicle is expected to increase further than the conventional vehicles with the internal combustion engine, that is IC engine. This forecast was based on four factors, namely customer changing sentiments regarding the EVs due to improved practically and the ownership cost, the favorable government policies, mostly in terms of financial incentives and accessibility of charging facilities. Car manufacturers business by strategy of putting more emphasis on EV related technologies and support from the companies outside of the car industry in adapting electric vehicle. The latest forecast conducted by firm Deloitte showed the percentage of electric vehicles global market share is reached up to 32% by the year 2030. This trend, when viewed with the tail tap emission perspective alone, the presents a post positive the outlook of the global environment, since the amount of harmful CO and CO2 and NOx emissions are expected to reduce gradually in transportation. The new challenge emerged from electric vehicle popularity. The increasing demand for electric vehicles are also causing electric demand to shoot up, and this leads to second challenge emerged from the increasing electric popularity. In some countries like China indicated that popularity of electric vehicle will strain not only its national grid but also to its national water supply. This is because in China two major contributors to power generation and hydroelectric and coal power plants, they rely heavily on the national water supply. Thus, building and operating additional hydroelectric dams and coal power plants to meet the demand of EV will divert vast amount of water away from the household usages. To address the challenge, two fundamental strategies must be seriously evaluated: efficient power grid management, which can be activated with via the implementation of vehicle to grid technology or implementation of extensive battery swapping activity, and efficient, sustainable and economical electrical vehicle power trains. Is a diagram for powertrain topologies. The components of electric vehicle powertrains. It mainly consists of batteries, an electric motor, and the transmission, and their performance can be identified in terms of efficiency and practicality. The highly efficient electric vehicle powertrain means that a power consumption per distance can be kept as low as possible, allowing the vehicle to increase the driving mileage. For practically, the target is to ensure the powertrain components are cost effective. The cost for production and operation can be kept as possible and sustainable with low carbon footprint from the production until application. The purpose of battery, the first component of EV vehicle powertrain, is to store the electricity from the electric motor's operation and to ensure that the powertrain is highly efficient and practical. The battery needs to have high energy density so that it can store a high amount of electric power without affecting its weight. Achieving this involves the implementation of new cathode, anode, and the electrolyte materials. However, according to the high battery temperature, if properly managed, also presents an opportunity to enhance its performance in delivering the electricity to the motor. Because of this, many researchers have proposed their active cooling method so that the battery temperature can be optimized to suit various driving conditions or emerging materials for the anode surface. The next major component of electric powertrain is electric motor, which is responsible for converting the electricity from the battery into mechanical power and to move the vehicle using the electromagnetic induction principle. The motor is controlled by an inverter that regulates the required current flow from the battery to suit the driving conditions. The electromagnetic field is produced using a current flow in the rotor conductor. Compared to the internal combustion engine, the volume of the both type is relatively more compact and they also have a high power to weight ratio. Not only that, but these motors also offer high torque capability at low motor speed, that is in RPM, which eliminates the requirement of high gear ratio for vehicle start and stop. It is an operation of flexible motors and it is a key to optimize the mechanical power flow in electric powertrain that can be realized by multi-speed transmission and multi-motor configuration. Optimizing the power flow in electric vehicle powertrains. Ensuring the single motor electric powertrain can operate optimally from the various driving conditions, especially from the vehicle is traveling in a high speed and low load is very challenging, and because of that their efficiency normally falls to around 60% from 90%. One of the possibilities to avoid this allowing flexible power flow configuration in the powertrain. When the loads are properly distributed, the motor's speed can be reduced drastically during the high vehicle speed and that contributes it's increasing the powertrain efficiency while ensuring the acceleration can be performed smoothly. The electric powertrains, this can be achieved by optimizing multi-motor configuration or by implementing multi-speed transmission in electric vehicle powertrain. This is a diagram for a IC engine powertrain and the electric vehicle powertrain. It is a literature based on research areas. It is a diagram for power drive trains. It consists of a cooling and lubrication system, shift mechanism, pressure valve control, pressure reducing valve, and the clamping force and control valve, speed ratio control valve, and the electric pump, the driven pulley, and the driving pulley, and the metal belts. Thank you.